Hey there, how's it going? Thanks for joining me today. Whether you're relaxing at home, on your commute, or winding down for the evening, I'm really glad you're here. Now, I want you to picture something with me. It's March 15th, 2019. It's late, probably close to midnight, and the Stanford Sleep Laboratory is mostly dark except for the soft glow of computer monitors. Sarah Chen is sitting in her chair, staring at readings that should be impossible. Her coffee has gone cold hours ago, but she hasn't noticed. She can't look away from what she's seeing. On one screen, clean, rhythmic brainwaves pulse in perfect 7 Hz theta patterns. These are the deep, slow waves you'd expect from someone in the middle stages of sleep. Nothing unusual there. Her test subject, a graduate student named Marcus, 24, is sleeping peacefully in the adjoining room, electrodes attached to his scalp, breathing steady and calm. But here's where things get weird, really weird. Next to Marcus's bed, curled up on a small cushion, is the laboratory's unofficial mascot, a grey tabby cat named Einstein. Einstein isn't part of any official study. He just showed up one day about 6 months earlier and made himself at home. The researchers started leaving food out for him, and eventually, Dr. Chen just accepted that Einstein lived there now. On this particular night, Einstein is purring. Nothing strange about that, right? Cats purr. It's what they do. But Dr. Chen has a second set of monitoring equipment running, equipment that's picking up Einstein's biological rhythms. And what she's seeing on that second screen is making her question everything she thought she knew about consciousness. Einstein's purr is resonating at exactly 7 Hz. Exactly the same frequency as Marcus's theta brain waves. Now, I know what you're thinking. Coincidence, right? Cats purr at all sorts of frequencies. But here's the thing that made Dr. Chen's hand start shaking as she reached for her phone to call her colleague. This synchronization had been going on for 2 hours and 17 minutes. Every time Marcus's brainwaves shifted, Einstein's purring frequency shifted with them. When Marcus briefly entered REM sleep and his brainwaves sped up, Einstein's purr accelerated to match. When Marcus settled back into deep theta, Einstein's purr slowed down again. Perfect synchronization. For over 2 hours, Dr. Chen sat there in the darkness, watching 2 different species breathing in unison, their biological rhythms locked together like dancers moving to the same song. But this wasn't the beginning of our story. Not even close. See, what Dr. Chen discovered that night was just the latest chapter in a mystery that goes back thousands and thousands of years. 4,000 years ago, in the temples of ancient Mesopotamia, priests were carving dreams into clay tablets. And you know what they always noted? When temple cats appeared in visions, they wrote about it obsessively, as if these feline dream visitors were incredibly significant. Think about that for a second. 4,000 years ago, people were already noticing something strange about dreams and animals. The ancient Egyptians took this even further. They built healing chambers, actual rooms designed for sleep, and the hieroglyphs that survive show humans sleeping beside animals, not just sleeping near them, but positioned in specific ways, with particular animals chosen for particular ailments. The Egyptian physicians seemed to believe that certain animals could influence the healing process during sleep, and it wasn't just cats and dogs. The Aboriginal peoples of Australia have been singing about dreamtime animal spirits for 50,000 years. 50,000 years! That's longer than recorded human history. They described a state of consciousness where human dreams and animal spirits merged, where the boundaries between species dissolved during sleep. The Vikings believed wolves could enter sleeping minds. They had elaborate rituals involving sleeping near wolf dens, believing that wolf consciousness could grant them strength and wisdom in their dreams. Medieval European texts describe similar practices, people sleeping in stables with horses before battles, or near aviaries filled with ravens when they needed to solve complex problems. Every culture, on every continent, seemed to discover pieces of the same puzzle. Indigenous peoples in the Amazon spoke of jaguar dreams that came only when jaguars slept nearby. Native American tribes described how buffalo herds could broadcast sleep frequencies across the plains, affecting the dreams of anyone sleeping within miles. Tibetan monks wrote about snow leopards that guided meditation and influenced the visions of practitioners who slept at high altitudes. But here's the crazy part. Modern science dismissed all of this as primitive thinking, folklore, superstition. For over a century, researchers insisted that consciousness was locked inside individual brains, that dreams were purely personal, isolated events. The idea that animals could influence human sleep patterns, ridiculous. Until that night in March 2019, when Dr. Sarah Chen watched her equipment prove that ancient wisdom had been right all along. Within 72 hours of Chen's discovery, the data was being replicated in laboratories around the world. Tokyo, Sao Paulo, London, Munich. Everywhere scientists pointed their equipment at sleeping humans and nearby animals, they found the same impossible synchronization. The brainwave patterns Chen recorded that night didn't just challenge a few academic theories, they shattered a century of sleep science. Everything we thought we knew about consciousness, about the nature of sleep, about the barriers between species, EZS, it all came crashing down in the space of a single night. But let me back up and tell you about the moments leading up to that discovery, because the details matter. Dr. Chen wasn't even studying interspecies consciousness. She was researching something completely different, the effects of ambient sound on sleep quality. Marcus was her volunteer test subject, and he'd been coming to the lab twice a week for about a month. Einstein had been showing up during these sessions, but Dr. Chen hadn't paid much attention. Cats like warm, quiet places, and the sleep lab fit the bill perfectly. Einstein would wander in, find a comfortable spot, and settle down for a nap. Sometimes he'd purr, sometimes he wouldn't. Just typical cat behavior. But on this particular night, something was different. Einstein had positioned himself unusually close to Marcus's bed, closer than he'd ever been before, and instead of his usual intermittent purring, he was maintaining a steady, continuous rumble. Dr. Chen almost didn't turn on the additional monitoring equipment. She was tired, it was late, and she just wanted to finish collecting her data and go home. But something about Einstein's behavior nagged at her. Professional curiosity, maybe, or just the scientist's instinct that something unusual was happening. So she hooked up a second set of sensors, not to Einstein directly, but positioned to pick up the acoustic and electromagnetic signatures of his purring. She figured she might as well document the ambient conditions completely, just to be thorough. For the first hour, she barely glanced at the additional readings. She was focused on Marcus's data, making notes about his sleep stages, tracking the progression from light sleep through deep sleep toward REM, standard stuff. It was around 11:45 p.m. when she happened to look at both screens simultaneously. And that's when she saw it. The patterns weren't just similar, they were identical. The frequency, the amplitude, even the subtle variations as Marcus moved through different phases of sleep. At first, she thought it was equipment malfunction, electromagnetic interference maybe, causing one signal to contaminate the other. She ran diagnostics, checked connections, even swapped out cables. Everything tested normal. Then she thought it might be coincidence. Cats do purr at frequencies that overlap with human brain waves, but as the minutes turned into hours and the synchronization remained perfect, coincidence became impossible to believe. By 2 a.m., Dr. Chen was frantically taking notes, documenting everything she could observe. Einstein's breathing rate had synchronized with Marcus's. Their heart rates were moving in harmony. Even their body temperatures seemed to be fluctuating together. She wanted to wake up Marcus and tell him what was happening, but she couldn't risk disrupting the phenomenon. Instead, she called Dr. James Reeves, her research partner, and whispered urgently into her phone, "You need to get down here right now. You're not going to believe what I'm seeing." Dr. Reeves arrived 20 minutes later, took one look at the synchronized readings, and said the words that would become legendary in sleep research circles. "Either our equipment is completely broken, or we just discovered something that's going to change everything." The equipment wasn't broken. As dawn approached and Marcus began to wake naturally, the synchronization gradually faded. Einstein stretched, yawned, and wandered off to find his breakfast, leaving behind only the impossible data that would reshape our understanding of consciousness itself. But here's what makes this story even more incredible. Dr. Chen's discovery wasn't really a discovery at all. It was a rediscovery. Ancient peoples had known about this connection for millennia. They just didn't have EEG machines to prove it. The night everything changed wasn't March 15th, 2019. It was the night, thousands of years ago, when the first human noticed that sleeping near animals brought different dreams, deeper rest, and stranger visions. The night everything changed was every night that indigenous shamans slept beside their animal guides, every time a Viking warrior shared consciousness with wolves, every moment an Egyptian priest experienced healing dreams in the company of temple cats. Dr. Chen's laboratory just gave us the scientific language to describe what our ancestors had always known. Consciousness isn't trapped inside individual skulls. It flows between species like water finding its level, creating connections that bridge the gap between human and animal experience. That night in Stanford, ancient wisdom met modern proof, and the implications of that meeting are still rippling outward, changing how we think about sleep, dreams, consciousness, and our relationship with every other living creature on this planet. What Dr. Chen discovered in those early morning hours was just the beginning, because once scientists started looking for this phenomenon, they found it everywhere. And what they found was so much stranger, so much more wonderful than anyone had imagined. In 1897, deep in the British countryside, a naturalist named Edmund Whitmore was having trouble sleeping, not because of insomnia or stress, but because his dreams had become so vivid, so startlingly real, that he'd started keeping a journal by his bedside to record them the moment he woke up. Now, you have to understand something about Edmund Whitmore. This was a man of science, methodical, skeptical, the kind of person who documented everything. He'd spent 20 years cataloguing bird species across the empire, had written 3 books on botanical classification, and was known among his peers for his rigorous attention to detail. He wasn't given to flights of fancy, but what was happening in his dreams was making him question everything he thought he knew about the natural world. Whitmore lived alone in a cottage on the edge of Sherwood Forest, except for his faithful companion, a border collie named Sage. Every night, Sage would curl up on a rug beside Whitmore's bed, and every morning Whitmore would wake with dreams so strange and detailed that he felt compelled to write them down. On July 23rd, 1897, he wrote in his journal, "Most extraordinary thing, dreamed again of running through fields, but this time from the perspective of something much closer to the ground, could smell scents with incredible detail, not just flowers and grass, but the individual tracks of rabbits, foxes, even field mice. Woke to find Sage's paws twitching, as if he too had been running." Here's where it gets really interesting. Whitmore started paying attention to the correlation between his dreams and Sage's sleeping behavior. When Sage slept deeply, Whitmore's dreams took on this ground-level, scent-filled quality. When Sage had restless nights, Whitmore's sleep was filled with dreams of chasing and herding. But Whitmore was a scientist, and he needed to test his theory. So he did something that sounds completely mad, By today's standards, he invited friends to sleep over, along with their dogs, and carefully documented everyone's dreams. The results were so consistent that Whitmore wrote frantically in his journal entry from September 15th. The most extraordinary thing, subjects sleeping near their dogs report identical dream imagery. Mrs. Hartford dreamed of digging and burying bones the same night her terrier, Pip, exhibited digging behaviors during sleep. Young Thomas experienced hunting dreams that perfectly matched his spaniel's observed sleep movements. But here's what's tragic about this story. Whitmore's work vanished, completely disappeared. When he died in 1904, his colleagues dismissed his dream research as the eccentric hobby of an aging naturalist. His family, embarrassed by what they considered his descent into pseudoscience, destroyed most of his papers. Most, but not all. In 2018, over a century later, contractors renovating a country house in Nottinghamshire discovered a trunk in the attic. Inside were dozens of Whitmore's journals, along with detailed charts, sketches, and what could only be described as the first systematic study of interspecies dream sharing ever conducted. But Whitmore wasn't alone in his observations. While his papers were gathering dust in that attic, other researchers around the world were documenting similar phenomena, often at great personal and professional cost. In 1923, deep in the Siberian wilderness, a Russian scientist named Dmitry Volkov was living among the Evenk people, studying their reindeer herding practices. What he discovered there would haunt him for the rest of his short life. The Evenk shamans had a practice they called dream riding. They would sleep in close proximity to their reindeer herds, claiming that the animals could carry their consciousness across vast distances during sleep. The shamans insisted they could experience what their reindeer experienced, feel the exact texture of snow under hooves, taste the specific lichens the animals preferred, even sense approaching weather patterns through the reindeer's natural instincts. Volkov was initially skeptical. He was there to study animal husbandry, not mystical practices. But night after night, sleeping in the traditional felt tents alongside the herders and their animals, he began to experience dreams unlike anything he'd ever known. Dreams where he moved in massive herds, where his vision stretched for miles across snow-covered tundra, where he could detect the approach of wolves hours before they appeared. In his detailed field notes, Volkov wrote, "The shamans speak truth. There exists some form of consciousness transfer during sleep states. The proximity to reindeer during rest produces dreams of remarkable clarity and detail, dreams that seem to originate from non-human perspectives. The animals themselves show synchronized sleep patterns when humans rest nearby." Volkov spent 2 years with the Evenk people, meticulously documenting these phenomena. He developed a theory that consciousness could be transmitted through what he called biological resonance frequencies. The idea that sleeping animals and humans could synchronize their brain activity under certain conditions. When he returned to Moscow in 1925, Volkov submitted his findings to the Soviet Academy of Sciences. The response was swift and brutal. His work was dismissed as bourgeois mysticism. Worse, during Stalin's purges in the 1930s, Volkov's research was specifically targeted as anti-Soviet propaganda that promoted primitive thinking over scientific materialism. Volkov himself disappeared in 1937. His research notes were confiscated and destroyed. For decades, his work existed only in fragments and whispered stories among the Evenk people he had lived with. Meanwhile, across the ocean, Native American tribes were watching Western scientists with a mixture of amusement and frustration. They'd been trying to share their knowledge about animal consciousness for generations, but their wisdom was consistently dismissed as primitive folklore. The Lakota described how buffalo herds could broadcast sleep frequencies across the Great Plains. Tribal elders spoke of sleeping under the stars during buffalo migrations and experiencing collective dreams, visions shared not just among the tribe, but with the animals themselves. They described dreams where they could sense the mood of entire herds, feel the animals' collective memory of ancient migration routes, even experience the buffalo's spiritual connection to the land. One Lakota medicine man, interviewed by an anthropologist in 1928, said, "You white people think consciousness lives only in your heads, but consciousness is like wind. It moves between all living things. When the buffalo dream, we dream with power. Them. When we dream, the buffalo know our thoughts." The Hopi elders had their own understanding of this phenomenon. They explained how snake dreams came from actual snakes sleeping in the desert around their villages. During certain seasons, when rattlesnakes gathered in large numbers in nearby dens, entire Hopi communities would experience similar serpentine dreams, visions of moving close to the ground, sensing heat signatures, understanding the desert from a completely different perspective. But Western scientists weren't listening. They filed these accounts under ethnographic curiosities and continued to insist that consciousness was an individual, human-specific phenomenon. In 1973, something remarkable happened in Kyoto, Japan. Dr. Akiko Tanaka was running sleep studies on laboratory mice when she noticed something that shouldn't have been possible. The grad students working late shifts in her lab were reporting unusually vivid dreams about running through mazes, hiding in small spaces, and experiencing the world from very low perspectives. Dr. Tanaka was intrigued enough to set up an informal experiment. She had volunteers sleep in the laboratory overnight, while EEG equipment monitored both the humans and the mice. What she recorded was the first electronic evidence of interspecies consciousness, sharing. Mice and humans showing synchronized REM patterns, their brainwaves pulsing in perfect harmony during deep sleep phases. She published her findings in a small, obscure journal called Consciousness and Interspecies Studies. The paper was maybe 5 pages long, filled with cautious language and hedge words like preliminary observations and requires further investigation. Despite her careful phrasing, the scientific community's response was predictably dismissive. Her colleagues questioned her methodology, suggested equipment malfunction, and privately whispered about Dr. Tanaka's professional judgment, funding for her. Research dried up. She was quietly pushed toward more conventional areas of study. The paper was cited exactly 3 times in 20 years, all by researchers working on completely unrelated topics. But Dr. Tanaka's work didn't disappear entirely. It found its way into underground networks of researchers and enthusiasts who were documenting similar phenomena. By the early 2000s, the internet had created a space for these scattered observations to come together. Forums with names like Interspecies Dreamers and Animal Consciousness Research began collecting anecdotal reports from around the world. Pet owners described dreams that seemed to originate from their animals' perspectives. Veterinarians shared stories of synchronized sleep patterns between therapy animals and their human patients. Zoo workers reported vivid dreams about life from the perspective of the animals they cared for. By 2015, these encrypted forums were buzzing with amateur researchers documenting their pets' sleep influence. People were conducting informal experiments, tracking their dreams in relation to their animals' sleep cycles, sharing data across continents. Sarah Martinez, a software engineer from Portland, spent 2 years documenting her dreams while sleeping next to her rescue parrot, Charlie. She recorded over 700 nights of data, noting dream content, sleep quality, and Charlie's behavior. Her spreadsheets showed clear correlations. Nights when Charlie was agitated produced anxiety dreams for Sarah, while peaceful parrot sleep led to dreams filled with flight and aerial perspectives. A group of college students in Berlin started the Urban Wildlife Dream Project, tracking how the city's animal populations influenced their sleep. They documented how sleeping with windows open during bird migration seasons produced dreams of long-distance flight, while proximity to the city's famous urban fox population led to dreams filled with keen night vision and acute hearing. All of this data was accumulating like snow before an avalanche, waiting for the right moment to break into mainstream consciousness. The evidence was there, scattered across continents, languages, and centuries, but there nonetheless. What's remarkable is how consistent the reports were, despite coming from completely different cultures, time periods, and contexts. Whether it was Edmund Whitmore's careful documentation in Victorian England, Dmitry Volkov's field notes from Siberia, Native American oral traditions, or modern internet forums, the same basic phenomenon kept appearing. Humans and animals sharing consciousness during sleep. The underground network of believers grew quietly but steadily. Veterinary schools started receiving questions about animal sleep patterns from pet owners who'd noticed dream correlations. Sleep clinics began hearing from patients who insisted their pets were influencing their dreams. Alternative medicine practitioners developed therapies based on sleeping near specific animals. By the time Dr. Sarah Chen made her discovery at Stanford in 2019, there were thousands of people around the world who weren't surprised by her findings. They'd been documenting the same phenomenon for years, just waiting for mainstream science to catch up. The tragic irony is that if scientists had been listening to indigenous wisdom, paying attention to historical accounts, and taking seriously the observations of people like Whitmore and Volkov, we might have understood interspecies consciousness sharing decades earlier. Instead, it took over a century for modern sleep research to confirm what shamans, pet owners, and careful observers had known all along. But once Chen's data broke through the academic barriers, everything changed. Suddenly, all those dismissed papers, forgotten journals, and ignored forum posts became valuable historical evidence. The hidden history of interspecies consciousness research emerged from the Recololi shadows, revealing a rich tradition of observation and documentation that had been waiting patiently for science to recognize its validity. The revolution didn't start in 2019. It had been building for over a century, one dismissed observation at a time. Here's what's happening in your bedroom right now, while you sleep, that you've probably never thought about. Let's say it's a typical Tuesday night. You've brushed your teeth, turned off the lights, and settled into bed. Maybe your cat, Luna, is curled up at the foot of your bed like she does every night. Maybe your dog, Max, is sleeping on his bed nearby. You think you're just going to sleep, 8 hours of unconscious downtime before tomorrow begins. But something extraordinary is about to happen. Something that connects you to a biological process that's been occurring for millions of years, long before humans even existed. As you drift from wakefulness into sleep, your brain begins to shift gears in a very specific way. Those busy, chattering beta waves, oscillating between 14 and 30 hertz, that characterize your awake, thinking mind, they start to slow down. Think of it like a car shifting from highway speed to neighborhood driving. First, you pass through alpha waves, those relaxed 8 to 14 hertz patterns that happen when you're drowsy but still aware. You know that floaty feeling right before you fall asleep? That's alpha. But you don't stay there long. Next comes theta, 4 to 8 hertz. This is where things get really interesting. Theta is the realm of deep relaxation, meditation, and most importantly for our story, the frequency where your brain becomes most receptive to external influences. Now here's where your sleeping brain gets truly fascinating. As you settle into those slow, rhythmic theta waves, if Luna is sleeping nearby, something remarkable starts to happen. Cats purr at a very specific frequency range, 25 to 50 hertz. But here's what most people don't know, that purring doesn't just make a pleasant sound. Those vibrations actually penetrate bone. They travel through your skull and reach deep into your brain tissue. Picture your skull like a drum. When Luna purrs at, say, 35 hertz, those vibrations resonate through the bone of your skull and reach a tiny, pine cone-shaped structure buried deep in your brain called the pineal gland. This little organ, about the size of a grain of rice, is what the philosopher René Descartes famously called the seat of the soul. The pineal gland contains something absolutely remarkable: magnetite crystals. These are the same crystals that help birds navigate during migration, that allow certain fish to sense magnetic fields, that give some animals their incredible directional abilities. And when cat purr vibrations hit these crystals, they start to vibrate too. This vibration triggers a cascade of chemical reactions. Your pineal gland begins producing increased amounts of a chemical called dimethyltryptamine, DMT. You might recognize that name if you've read about psychedelic research or shamanic practices. DMT is often called the spirit molecule because it's the same chemical that floods your brain during intense spiritual experiences, near-death experiences, and most relevant to our story, during dreams. So when Luna purrs while you sleep, she's literally tuning your brain to produce more of the chemical that makes dreaming possible. But cats aren't the only animals affecting your sleep in ways you never imagined. Let's talk about dogs. Dogs have remarkably powerful hearts, much more powerful than ours relative to their body size. These hearts generate electromagnetic fields that pulse at very specific frequencies. When Max sleeps near you, his heart is broadcasting electromagnetic signals at 0.1 Hz, perfectly matching the delta waves your brain produces during the deepest stages of sleep. Think about that for a moment. Your dog's heart is literally synchronizing with your brain's sleep rhythms. Fish take this even further. If you've ever slept near an aquarium, you've been exposed to something scientists are just beginning to understand. Many fish species generate electrical fields, not strong ones, but detectable ones. These fields pulse at frequencies that perfectly match what researchers call sleep spindles, those brief bursts of brain activity that help transition you from light sleep to deep sleep. And birds? They're perhaps the most sophisticated of all. You know how birds start singing right before dawn? That's not random. They're singing at specific frequencies that trigger cortisol release in mammals, essentially providing a natural alarm clock that wakes you gradually and naturally, instead of the jarring shock of an electronic alarm. But how does all this actually work? How can animal behavior influence something as personal and internal as your dreams? The mechanism involves 3 systems in your body working together, like instruments in an orchestra. First, there's electromagnetic resonance. Every living creature generates biofields, subtle electromagnetic signatures created by the electrical activity of our nervous systems and hearts. When you sleep near animals, these biofields can synchronize, like tuning forks resonating together. Second, there's acoustic transmission. This isn't just about hearing sounds while you sleep. It's about bone conduction, vibrations that travel through your skull and directly stimulate brain tissue. Cat purrs, dog heartbeats, even the subtle breathing patterns of sleeping animals create vibrations that your brain can detect and respond to even when you're unconscious. Third, there's chemical signaling through synchronized pheromone release. Animals and humans both release chemical signals during sleep, pheromones that can influence mood, stress levels, and brain chemistry. When you sleep in close proximity to animals, you're essentially sharing a chemical environment that can influence each other's sleep states. Your limbic system, FI, the ancient emotional center of your brain, responds most strongly to these influences. Brain scans show that when people sleep near animals, their amygdala, CU1, the part of the brain that processes emotions and memories, lights up in perfect synchrony with the animals nearby. This synchronization happens in the amygdala because this brain region is evolutionarily ancient. It's part of what scientists call the reptilian brain, structures that developed hundreds of millions of years ago, long before higher reasoning abilities evolved. This ancient brain doesn't distinguish between species the way our conscious minds do. It simply responds to the biological rhythms and energy patterns of nearby living creatures. But here's where this gets really mind-bending. The pineal gland, remember, that little pine cone-shaped structure that contains magnetite crystals, is directly connected to your optic nerve. Even though your eyes are closed during sleep, the pineal gland can still detect light changes, magnetic field variations, and electromagnetic fluctuations from nearby animals. When animals sleep, they enter different phases of rest, just like humans do. Cats, for instance, spend about 75% of their sleep time in light sleep and 25% in deep sleep. During their deep sleep phases, cats' purring changes frequency, their heart rates slow, and their electromagnetic signatures shift. Your sleeping brain detects these changes and responds by shifting its own patterns to match. It's as if your neurons are constantly listening to a biological radio station broadcast by nearby animals and tuning in to harmonize with whatever frequency they're transmitting. Dogs have an even more complex sleep architecture. They cycle through light sleep, deep sleep, and REM sleep approximately every 20 minutes. During each phase, they emit different electromagnetic patterns, different breathing rhythms, different chemical signatures. Your brain, detecting these shifts, begins to cycle its own sleep stages to synchronize with your dog's patterns. This is why people who sleep with dogs often report more restful sleep. Their sleep cycles become more regular and efficient because they're being guided by their pet's natural rhythms. But perhaps the most remarkable discovery in recent research involves mirror neurons, specialized brain cells that fire both when you perform an action and when you observe someone else performing the same action. Scientists have discovered that these mirror neurons remain active during sleep, and they can be triggered by the sleeping behaviors of nearby animals. When your cat stretches and repositions during sleep, your mirror neurons fire as if you were stretching. When your dog dreams, a dode, and yes, dogs definitely dream, as evidenced by their paw movements and vocalizations during REM sleep, your mirror neurons activate as if you were experiencing the same dream movements. This creates a kind of neurological empathy that operates below the level of consciousness. Your sleeping brain is literally mirroring the experiences of animals sleeping nearby. The neurotransmitter systems involved in this process are incredibly complex. During normal sleep, your brain produces specific chemicals at specific times: melatonin to initiate sleep, GABA to maintain deep sleep, acetylcholine to trigger REM sleep and dreaming. But when animals are present, additional chemicals come into play. Oxytocin, INIWEL, often called the bonding hormone, increases significantly when humans and animals sleep in proximity. This chemical doesn't just make you feel emotionally connected to your pets, it actually changes your brain's receptivity to their biological signals. Dopamine patterns also shift. The reward pathways in your brain become more active during sleep when animals are present, which you may explain why people often report more pleasant, more vivid dreams when sleeping near their pets. Even your stress hormone cortisol follows different patterns. Normally, cortisol levels drop during sleep and rise before waking. But when animals are present, this pattern becomes more gradual and natural, leading to less stressful wake-ups and better mood regulation. Now, different animals affect your sleep in different ways, and understanding these differences opens up fascinating possibilities for therapeutic applications. Cats, with their purring frequencies, seem to enhance the production of healing chemicals in your brain, not just DMT for dreaming, but also growth hormone and endorphins. This might explain why people recovering from illness often sleep better when they have cats nearby. Dogs, with their electromagnetic heart patterns, appear to regulate your autonomic nervous system, says Meyer. The automatic functions like heart rate, breathing, and blood pressure. People with anxiety or heart conditions often show measurably improved sleep quality when sleeping near dogs. Rabbits, interestingly, seem to have a calming effect on the nervous system. Their very rapid heart rates, around 200 beats per minute, create high-frequency electromagnetic patterns that appear to reduce cortisol production and increase GABA levels in nearby humans. Birds affect sleep differently depending on the species. Songbirds create acoustic patterns that seem to enhance REM sleep and dream vividness. Larger birds, like parrots, generate different electromagnetic signatures that appear to promote deeper, more restorative sleep stages. Even fish in bedroom aquariums create measurable effects. The gentle bubbling of aquarium filters, combined with the subtle electrical patterns generated by swimming fish, creates what researchers call pink noise, sound frequencies that have been shown to improve sleep quality and memory consolidation. But here's perhaps the most remarkable, the discovery of all. Your brain doesn't just passively receive these animal influences, it actively seeks them out. Sleep researchers have discovered that when people who normally sleep with pets spend nights alone, their brains actually produce less DMT, less growth hormone, and lower levels of the neurotransmitters associated with restorative sleep. It's as if the human brain has evolved to expect these animal influences and struggles to achieve optimal sleep without them. This suggests that the relationship between human and animal consciousness during sleep isn't just incidental, it might be essential. Evolution may have shaped our brains to require these interspecies connections for optimal functioning. Think about our ancestors, sleeping around fires with domesticated dogs and cats nearby. Think about indigenous peoples who still sleep in close proximity to animals. Think about the fact that humans have been sharing sleeping spaces with animals for thousands and thousands of years. Our brains may have evolved to treat sleeping alone, without any animal presence, as an abnormal, stressful condition. The rise in sleep disorders in modern urban environments might be partly explained by our increasing isolation from animals during rest. Every night, when you settle into bed with Luna curled up nearby or Max sleeping on his cushion, you're participating in a biological symphony that's been playing for millions of years. Your brain waves, your pet's purr, the electromagnetic fields generated by your hearts, the chemical signals you both release, NGLI, they're all combining to create a shared state of consciousness that transcends individual species boundaries. You're not just sleeping near an animal, you're joining a collective consciousness that includes every living creature in your immediate environment. And that consciousness is actively shaping your dreams, your rest quality, your brain chemistry, and ultimately, your waking life. Tomorrow night, when you go to sleep, pay attention to the animals around you. Notice their breathing, their movements, their presence. Because they're not just sharing your space, they're sharing your consciousness, one brain wave at a time. Dr. Marina Chen first noticed something was wrong, or maybe something was perfectly right, in late 2017. She was a behavioral neuroscientist at UC San Diego, studying spatial memory in laboratory mice. Standard stuff, really. Maze navigation, reward patterns, the kind of research that had been done thousands of times before. But Marina had a habit that her colleagues thought was a bit odd. During her long afternoon data collection sessions, she'd sometimes take brief naps on the small couch in her laboratory office. The work was tedious, watching mice run through mazes for hours at a time, and a 20-minute power nap helped her stay alert for the evening sessions. She started noticing that her laboratory mice behaved strangely during these afternoon naps. Instead of continuing their normal cage activities, they would cluster together near the side of their enclosures closest to her couch. Not just one or two mice, but entire cages full of them, all pressed against the plastic walls, as close to her sleeping form as they could get. At first, Marina thought it might be a feeding time association. Maybe the mice had learned that her naps preceded their afternoon feeding schedule. But when she tested this theory by changing feeding times, the clustering behavior remained unchanged. The mice were specifically drawn to her sleeping presence, not to anticipated food. Being a scientist, Marina did what scientists do. She started documenting everything. She set up a video camera to record the mouse behavior during her naps. What she saw in the footage was even stranger than she'd expected. The mice weren't just clustering near her, they were exhibiting synchronized behaviors. When she entered deep sleep phases, which she tracked by, monitoring her own breathing and heart rate patterns, the mice would settle into unusually calm, almost meditative postures. When she shifted or entered lighter sleep, the mice would become more active, but still remain clustered near her location. Then Marina made a decision that would change her career forever. She brought EEG equipment into her office. Setting up brain monitoring equipment in a mouse behavioral lab wasn't easy. Marina had to jerry-rig sensors, calibrate equipment meant for human subjects to work with mice, and figure out how to record from multiple species simultaneously. Her colleagues thought she'd lost her mind. Dr. James Hartwell, the lab director, pulled her aside one afternoon and said, "Marina, you're a brilliant researcher, but this is starting to look like pseudoscience. EEG on mice is one thing, but trying to correlate it with your own sleep patterns, I'm worried about where this is heading." But Marina couldn't let it go. On November 3, 2017, she finally got her equipment calibrated and running. That afternoon, she settled onto her couch for what she expected would be just another documented nap session. What happened instead would haunt her dreams for months to come. The EEG readings showed something that should have been impossible. During the deepest phase of her 23-minute nap, her brain waves and the collective brain waves of the nearby mice synchronized perfectly. Not similar, identical. The same frequency, the same amplitude, even the same subtle variations and fluctuations. Marina faced a choice that every revolutionary scientist eventually confronts: ignore the impossible data and continue with conventional research, or risk everything to pursue what the evidence was telling her. She chose truth. Marina spent the next 6 months conducting increasingly sophisticated experiments. She recruited volunteer grad students to nap in the laboratory, while she monitored both human and mouse brain activity. She varied the distances between humans and mice, tested different numbers of animals, even tried separating the species with various materials to see if the effect could be blocked. The results were consistent and terrifying in their implications. Humans and mice could indeed synchronize brain activity during sleep states. The effect was strongest within 3 feet, worked through most materials except thick metal barriers, and seemed to be enhanced when the humans were familiar with the specific mice they were sleeping near. When Marina submitted her first paper on these findings to the Journal of Neuroscience, the rejection letter was brutal. The reviewer comments included phrases like methodologically unsound, extraordinary claims require extraordinary evidence, and most damaging of all, appears to conflate correlation with causation in ways that suggest fundamental misunderstanding of neuroscientific principles. Marina revised the paper, submitted it to 5 more journals, and received 5 more rejections. Colleagues started avoiding her at conferences. Funding applications were denied without explanation. Word spread through the small world of neuroscience research that Marina Chen had gone off the deep end. But Marina wasn't the only scientist facing professional exile for following the evidence wherever it led. 3,000 miles away in San Diego, Dr. James Thornfield was having his own crisis of scientific faith. James was a marine biologist who had been swimming with dolphins for 30 years. He started as a graduate student studying dolphin communication, fell in love with the work, and had spent most of his career in and around the water with these remarkable creatures. James had always felt that there was something almost mystical about swimming with dolphins, but he chalked it up to the natural high of being in the ocean with such intelligent animals. Until 2018, when he decided to bring EEG equipment into Cruve, the water, with him. Waterproof EEG technology was still experimental in 2018, but James managed to cobble together a system that could record his brain activity while he floated among dolphin pods in the protected waters off La Jolla. What he discovered during these underwater meditation sessions changed everything he thought he knew about interspecies communication. Dolphins generate sonar clicks almost constantly, rapid-fire acoustic pulses they use for navigation and hunting. But James discovered that when dolphins were in a relaxed, social mode, IST, what marine biologists call rest state, their sonar patterns shifted to very specific frequencies. And those frequencies, James realized with growing excitement and terror, were inducing altered states of consciousness in nearby humans. The EEG readings were unmistakable. When dolphins clicked at frequencies between 6 and 8 Hz, James's brainwaves shifted into deep theta states, the same patterns associated with profound meditation, shamanic journeying, and mystical experiences. When the dolphins shifted to faster click patterns, his brainwaves followed, moving through alpha and beta frequencies in perfect synchronization. James had discovered that dolphins weren't just communicating with sound, they were actively modulating the consciousness of nearby humans through precisely controlled acoustic frequencies. The implications were staggering. Had dolphins evolved the ability to influence human consciousness? Were they deliberately inducing these altered states? And if so, what were they trying to communicate? James submitted his findings to 3 marine biology conferences. He was rejected from all 3, with review comments that questioned not just his methodology but his professional competence. One reviewer wrote, "This research appears to be based on New Age mysticism rather than rigorous scientific inquiry. The author seems to have conflated personal spiritual experiences with objective data collection." The ridicule was immediate and devastating. James was banned from presenting at the International Marine Mammal Society conference. Funding for his research was discontinued. Colleagues who had worked with him for decades suddenly became unavailable for collaboration, but the data didn't lie, and James wasn't backing down. Meanwhile, in Osaka, Japan, Dr. Yuki Nakamura was making her own shocking discoveries about consciousness and cephalopods. Yuki ran a laboratory studying octopus intelligence and behavior, and she'd always been fascinated by these creatures' almost alien form of consciousness. Octopi have 8 semi-independent brains, 1 central brain and 1 smaller brain in each arm. They can change color and texture in response to their emotional states, solve complex puzzles, and demonstrate behaviors that suggest self-awareness and planning abilities. Yuki had been working night shifts in her laboratory for several months, catching up on data analysis while the octopi went through their rest cycles. She started noticing that on nights when she fell asleep at her desk, the octopi in nearby tanks exhibited unusual behaviors. Instead of their normal pale, mottled rest coloration, they would display vivid, swirling patterns of color that seemed almost hypnotic. These displays would continue for hours, only returning to normal when Yuki woke up. More disturbing, Yuki began experiencing dreams unlike anything she'd ever known. The dreams where she moved through water with boneless fluidity, where she could taste and smell through her skin, where her consciousness seemed to spread across multiple independent thinking centers. When Yuki brought sleep monitoring equipment into the laboratory, she discovered something that challenged everything neuroscientists thought they knew about consciousness. The octopi were somehow influencing her sleep states, creating shared dream experiences that seemed to originate from their radically different form of neural organization. The paper Yuki wrote about these experiences was rejected by every journal she submitted it to. Colleagues called her work anthropomorphic fantasy and suggested she might be suffering from sleep deprivation hallucinations. The Japanese Marine Biology Society formally censured her for conducting unethical experiments involving human subjects without proper oversight. Yuki's research funding was revoked. Her laboratory access was restricted. She was effectively forced out of mainstream academic research. In Brazil, Dr. Paulo Santos was facing similar professional destruction for his work with therapy horses and human sleep patterns. Paulo was a psychiatrist who had been using equine-assisted therapy to treat patients with PTSD and severe depression. He'd noticed that patients who spent nights sleeping in the stable areas near therapy horses showed remarkably rapid improvement in their symptoms. Curious about this phenomenon, Paulo began monitoring both human and horse brain activity during these overnight sessions. What he discovered was that horses generate extremely low-frequency electromagnetic fields, AM, around 0.1 to 0.3 Hz, that seem to regulate human stress hormones and promote deep, restorative sleep. Patients sleeping near therapy horses experienced 90% reduction in nightmares, 75% improvement in sleep quality scores, and significant decreases in cortisol levels and other stress markers. The horses themselves seem to respond to human emotional states, with their electromagnetic patterns shifting to provide exactly the kind of neurological support each patient needed. When Paulo published his findings, the Brazilian Medical Board threatened to revoke his license to practice psychiatry. They accused him of promoting unscientific treatment modalities and endangering patient welfare through experimental procedures lacking proper validation. Paulo's clinic was investigated, his patients were interviewed by medical board officials, and his research was dismissed as placebo effect, masquerading as biological intervention. Several colleagues publicly distanced themselves from his work, publishing papers that criticized equine-assisted therapy as expensive pseudoscience with no measurable benefits. But Paulo's patients knew better. They had experienced the profound healing that came from sleeping near horses, had felt their nightmares fade and their sleep patterns normalize in ways that years of traditional therapy and medication had never achieved. These four scientists, Marina, James, Yuki, and Paulo, found each other through the only network available to researchers pursuing forbidden knowledge, encrypted online forums and underground academic networks. The Consciousness Research Underground, as they called themselves, began sharing data through secure channels. They developed protocols for replicating each other's experiments, created standardized measurement techniques, and built a database of evidence that traditional academic institutions refused to acknowledge. By late 2018, their network had grown to include dozens of researchers from around the world. Dr. Sarah Hoffman in Berlin was documenting how urban birds influence the sleep patterns of nearby humans. Dr. Michael Torres in Mexico City had discovered that sleeping near iguanas produced measurable changes in human dream content. Dr. Lisa Wong in Vancouver was studying how sleeping fish affected the sleep architecture of aquarium workers. Each researcher faced the same pattern of professional destruction: initial skepticism, experimental replication, data collection, peer review, rejection, funding cuts, and eventual academic exile. But collectively, they were building an undeniable body of evidence. The network developed its own peer review process, its own standards for experimental rigor, and its own publication system. They called their journal Interspecies Consciousness Studies, and while it had no official academic recognition, it maintained higher standards of statistical analysis and experimental replication than many mainstream publications. By 2019, they had documented over 300 cases of interspecies consciousness sharing across 6 continents. The evidence included brain scans, sleep architecture analysis, biochemical markers, behavioral observations, and longitudinal studies tracking both human and animal subjects over months and years.